Welcome back to the Lowdown on Physics. This is screencast number 4 for Unit 1 VCE Physics Basic Electric Circuits. Today we'll be looking at resistance. Now, resistance can be thought of as really the number of volts or how much energy is going to be required to make a current of 1 amp flow through a conductor. So as far as formal definitions go, we'd say the ratio of potential difference to current. So R equals V over I. We give it the unit ohms, which really is an alternative unit for volts per ampere. Basically, the resistance is going to determine just how much current can flow for a given voltage. So Ohm's law, this is a guy who was investigating the effects of temperature and keeping the temperature constant and how current and resistance changed, voltage changed. And basically what it states is that, you know, if you keep a metal at constant temperature, the current will remain proportional to voltage. So voltage is proportional to current, or V equals IR. It depends on the amount of resistance. So specifically looking at ohmic conductors, they will maintain a constant resistance. We can use that if we know the voltage and the resistance, we can work out how much current will flow and vice versa. So you'll notice that I use the word ohmic conductors there because there are conductors that are ohmic, that's a constant resistance, so as voltage increases, current increases proportionally. And there are those that are non-ohmic, like say an incandescent light bulb filament. As it heats up, more voltage going through, the resistance will increase, so there is less current that's going to flow. Then we've got semiconductors like an LED or a diode, which will have very little current flowing initially, and then the current will increase rapidly with a small increase in voltage, so they don't maintain a constant resistance. So let's have a look at a basic example of how to use this equation. So you've got a 20 ohm resistor. You want to work out what current's going to flow for some given voltages. So if it's 2 volts, we want to rearrange V equals IR so that we've got I as the subject. So rearranging, I will equal V over R, and then we can substitute in. We've got 2 volts, we've got 20 ohms of resistance, so 2 over 20, 0.1 amperes of current can flow. If we put 40 volts in, assuming the resistor could cope with that, then whoops, backwards. I equals V over R. We've got 40 over 20, and then you'd have 2 amps of current flowing. Now, generally, we're not going to have nice, simple circuits which just involve one power supply and one resistor. We're going to have a number of resistors. The easiest one for us to work on would be when we replace them all in series with one another. So if we've got them in series, if we think about the voltages, we had V equals V1 plus V2 plus V3 plus so on, so on, so on. Now, using Ohm's law, V equals IR. So if we substitute in IR in place of V for the power supply and the voltage across each of the resistors in series, and then because they're in series, the current will be the same, divide out the current, what we're left with is the total resistance when they're in series is just the sum of each of the resistances. So just add them together and that will give you your total resistance. The reason that we would tend to do that is for calculations involving or determining current or the total voltage, or given bits of information. Sometimes it's much easier to work with a single resistance. Okay, so that's series. What happens when we put them in parallel is, let's go back to our current and voltage. The current splits up. So we've got the power supply, the current goes through each of the individual different pathways. So if we think about it, I is the same as V over R, rearranging Ohm's law there. So we've got the power supply over the resistance in parallel, or the total voltage over parallel. the resistance in parallel, will equal V1 over R1 plus V2 over R2 plus V3 over R3. And what's happening here is that the voltage of the power supply will be the same as V1, the same as V2, same as V3. So again, we can cancel each of those out, which will give us our equation that 1 on R parallel equals 1 on R1 plus 1 on R2 plus 1 on R3 plus however many there are. So we're adding the inverses. If you don't quite understand this, you can ask me about it in class, but the derivation's not super critical, not as critical as the use of this formula here. So let's have a quick look at an example. We've got a 30 ohm resistor, a 20 ohm resistor. They're going to be connected to 12 volt power supply. Determine the current if we connected each of them individually. So say we connect the 30 ohm resistor, what are we going to get? I equals V over R. So we've got a voltage of 12 divided by our resistance of 30. We get a current flowing of 0.4 amps. If we do that for the 20 ohm resistor, then we have 12 divided by 20, we get 0.6 amps. Okay, it's 2/3 the resistance, so we expect that we're going to get about a 50% increase. Okay, or 50% more resistance, so we will have a 50% increase here. So what happens if we connect them in series? Well, we need to know the total resistance first. So we've got 20 plus 30, we're going to get a 50 ohm resistance. Given the 50 ohm resistance, we can now complete our calculation for current. V over R, we've got 12 over 50, which is 0.24 amps. So notice by increasing the resistance, there's going to be a reduction in the size of the current. Okay, increase resistance, current goes down. That's V equals IR. If one goes up, one's got to come down. And finally, if we go connecting them in parallel, 1 on 20 plus 1 on 30 equals 5 on 60. That's for 1 on RT. So to work out the resistance in parallel, we have to then take the inverse of that sum. So that means flipping this upside down. So we've got 60 divided by 5 and 12 ohms as our resistance. What you'll notice here is this resistance is smaller than both of the resistances that we've added. And that will always be the case in parallel. Whenever you add resistances in parallel, it will be less than the smallest resistance. Now that we've got our total resistance, we can calculate the current. So it's going to be 12 over 12, 1 amp of current is going to flow through the power supply, and then that will get split up through the pathways. And one last thing I wanted to show you is if you have identical resistors in parallel, then it's just going to be, to find the total resistance, you're going to divide by the number of resistors in parallel. So for example, if we had 150, 150 and 150, if we did the sum, we do 1 on 150 plus 1 on 150 plus 1 on 150. That gives us 3 over 150. So when we take that inverse, it's going to become 150 over 3. So that only occurs when it's the identical resistors. If they're all the same resistance, you just divide by the total number, and that will give you the equivalent resistance if you were to replace it with a single resistor. Okay, that's it. Thanks folks. I'll see you in class shortly.